All right, so let's look at a couple other things with statistics. All right, so it says express the sample proportion as a percent. So don't overthink this. Okay, out of 80 students, 21 have a black car. So what percent of students have black cars? What would we do? No. Yes. Can someone do that, please? What do we get?
26%.
Questions? Okay. All right, margin of error. So over here on the left, margin of error, when objects or people are randomly selected from a large population, there will be a margin of error. So basically, you take a sample of people, you get a statistic from them, like the proportion of people who smoke. You didn't ask every single person in the population, most likely because it would cost too much money to do that if you were trying to survey people. So you try to keep your costs down. So you just take a random sample of people and ask them if they smoke or not. And then you're going to get this margin of error, so this range of numbers on either side that you say the true proportion is probably somewhere in here. Okay. So, for example, a poll reports that 35% of voters favor candidate B with a margin of error of 3%. So basically, they're saying they took this 35% and they added and subtracted 3 to give us this range right here of 32% to 38%. Okay, so that's the margin of error. You have your central number, the 35, and then how far you go above and below that number. That's your margin of error. Okay, sometimes they're going to ask you to just say what the margin of error would be. Okay, so looking at this example right here, if we have 500, we take 1 divided by the square root of 500 and we get 4%. Okay, so use 1 divided by the square root of your sample size. So that is your kind of rule of thumb here. So an n is usually the sample size. Okay, so it's 1 over the square root of n. That's how you calculate margin of error. Okay, what if they want you to work backwards and they say, we calculated a margin of error of 6.5%. What is the sample size? So now we're solving for n. And 6.5%, we want to change that over to a decimal so that we can actually do some solving. So we write it as 0.065. How would we do this? How would we solve for n? And what should we do to both sides? Close. We're going to multiply the square root of n. That way we get rid of our fraction. Okay, so now over here we just got 1, 0.065 root n. Now what? Divide 0.065. Okay, so now over here we've got square root of n equals what? Okay, and then what's the last step? Not square root it. Square it. Square both sides. Okay, so what's that going to be? Our sample size. What do we get? Point what? Okay, so since this is a sample size, we need whole numbers. So we'll say 237. Okay, so the sample was 237 people or objects, depending on what it was. All right, bias. Bias is where one outcome is more likely than another. Okay, so if you're in a situation and you know ahead of time that one answer, either candidate A or B, is more likely to happen, then there is a bias. So we try to get rid of bias whenever we're doing samples and things like that, but sometimes we can't avoid it 100%, but we try to reduce it as much as possible. So for instance, if you were wanting to know who the best basketball team was, high school basketball team. Would you want to sample people just from Lake City, or would you want to sample a few kids from each school? Probably each school, because people from here are going to be biased towards our own team. That's what bias is. So try to minimize that by taking better samples of people. All right, so we're going to look at these situations and determine if there's bias and figure out a way if we could fix it to get a better sample. So looking here, viewers of the Heavy Metal Music Awards are asked to call in and name their favorite artist. Is there bias? Yes, there's bias. What would they be biased towards? Mm, they're going to be biased towards a heavy metal artist. Yeah. They're not going to probably say a country artist or anything like that. Okay, so this is definitely going to have bias. Okay, because, oh, jeepers, that didn't work out. We'll come back to that. Okay, so they would be biased toward heavy metal. Okay, because if they're watching the Heavy Metal Music Awards, they're probably fans of heavy metal music. Okay, so how could we get a better sample? How could we conduct a survey? Maybe ask people at a grocery store or something that's unrelated to music. Okay, so sample people. I could say shopping at Target or something. You could stand by the music section and just ask people there. That wouldn't be the absolute best way. The best way would be just to do like a random phone call, look through the phone book and do things like that. But this is at least better than polling from the Heavy Metal Music Awards. Okay, this one, a magazine asks its readers to fill out and send in a questionnaire. How come? So let's get more specific. Let's say this is a gardening magazine. It's going to ask its readers to fill in a questionnaire. Are they going to get unbiased results on those questions? No, because these are just a small population of gardeners. Okay, so unbiased samples are people of all walks of life. Okay, because it's so confined to just a single group of people who subscribe to a specific magazine, it's going to be biased. Okay, so they are biased toward gardening. So you'd want to use a more random sample. Okay. Next one, school newspaper interviews 20 random students about homecoming. This one is actually unbiased. Why is it unbiased? Okay, it's random. We're not asking the people in the school about opinions of other schools. They're just wanting a opinion about their own specific homecoming. So their whole population is their school. That's as wide as it's going to get. The questions up here are wanting to answer questions about a bigger population. So what is everyone's favorite artist? Well, they only asked a very small pool of people, the heavy metal people, who their favorite artist is, not everyone. So if our goal is to find out our school's opinion about our homecoming celebration to see how we could improve it, if they take a random sample of people, of kids in this school to ask them about it, that would be unbiased. Does that make sense? Do you see the difference between the two? Our goal is to just get information about our own personal homecoming. So this one is unbiased. Okay, almost done here. Okay, calculators dropped on the ground 360 times in a year in my classroom. Of those times, 96 caused damage to the calculator. I made those up, by the way, but we're going to answer a couple of questions on this. So we want to find the sample proportion. What do you think I mean by that? Sample proportion of what? Damaged calculators. Okay, so what proportion were damaged? How could we say that? Well, proportion is a fraction, remember, so how could we write it? 96 over 360, and what is that as a decimal? 0. What? Give me 3 numbers after. Okay, so the proportion of calculators that were damaged was 0.266, or about 27%. Okay, how would we find the margin of error? What was our formula for doing that? 1 over square root of, okay, and what was n? Our sample size, which was 360. Okay, so someone tell me what this is.
Right, 0.0527.
Okay, so let's think about both of these in terms of percents. So this right here, 26.6%, and this is 5.3%. So then the question that they're going to ask you on the homework and also on the test is to find the interval likely to contain the true population proportion of broken calculators. Okay, so our sample just from this year was 26%, but what is the range going to be? What would we do? Similar to that candidate example we talked about a few slides ago. 21.3 to 31.9. And how are we getting these numbers? Here's our central number. And what we're doing is we're subtracting 5.3 from this, and we're adding 5.3 to that. And that gives us that range that we think the true proportion of broken calculators would be like in the whole school, for instance. Questions there? Looks like we got it right. Okay. Questions? We good?